In this video, I'm going to show you how to prove limits using the precise definition. I'm going to talk about the logic behind it, and I'm going to show you 3 examples so that you can really see how it's done. So in all of these problems, we're going to be proving an if-then statement. So the general form of it is like this: if A, then C. A is called the antecedent, and C is called the consequent. So the way we prove an if-then statement is to assume that A is true, and then we have to show step by step logically that C then follows. Once you can show that C is true, so show that C is true, then you can conclude if A, then C. All right, so the reason I'm telling you this is because we're going to be using this this as a general procedure in solving these problems. So the first example, we have a limit as x goes to -3 of 2x plus 1. Now, if we plug in -3 for x here, we just get that's -6 plus 1. It's going to be -5. Now, the way we show, we prove that this is, we prove this limit using the precise definition. We write if our variable here is x, and then minus whatever this number is, -3, less than delta, then, and now I'm going to put my function here, which is 2x plus 1, and then minus whatever this is, -5. This is less than epsilon. So, as I said, the goal here is to assume that the antecedent is true and then show how it follows that the consequent is true. But first, we have a problem, and that is we need to know what delta is. That is our first step. And the way we find it is by working backwards. So off to the side here, I'm going to start out with the consequent. So 2x plus 1 plus 5, that's going to be 2x plus 6 less than epsilon. And the goal is to make whatever this is look like the antecedent. So this is going to be x plus 3, right? I can get x plus 3 here by factoring a 2. So this is going to be 2 x plus 3 less than epsilon. And now if I divide both sides by 2, I get absolute value x plus 3 less than epsilon over 2. So I am going to choose delta equal epsilon over 2. Now I can begin the argument. So assume x minus -3 less than delta. So then x plus 3 less than, I said that delta is epsilon over 2, so less than epsilon over 2. And now I'm going to multiply both sides by 2. So this gives me 2 epsilon value x plus 3 less than epsilon. And now I'm going to distribute the 2, and this gives me 2x plus 6 less than epsilon. And I'm going to rewrite it as, or what's in the absolute value as 2x plus 1 minus -5 less than epsilon. This is the consequent. We have just gone from the antecedent, and we showed step by step how to get the consequent from that. So we have proven the limit using the precise definition. So therefore, limit x goes to -3 2x plus 1 equals negative 5. And we're done. I'm going to give you one more example. Let's take, for example, a limit x goes to 7 of negative 5x plus 1. So if I plug in 7 for x, that gives me negative 35 plus 1. That's negative 34. And I want to prove this using the precise definition. So this is analogous to showing that if x minus 7 less than delta, then, let's see, our function here, negative 5x plus 1, and then minus negative 34, this is less than epsilon. So as before, I'm going to work backwards to find out what delta I should choose. So off to the side here, I start out with the consequent. So this is going to be combining like terms here. This is negative 5x, and then 1 plus 34. That's 35. And because this is an absolute value, I can multiply by the inside by negative 1 without changing anything. And I'm going to factor, or I'll just factor negative 5. So negative 5 x minus 7. And the reason I'm factoring this out is so that I can make it look like what's in the antecedent. So x minus 7 here, and I have x minus 7 here. So this is going to be 5, x minus 7 less than epsilon. Divide both sides by 5. That gives me x minus 7 less than epsilon over 5. So comparing the antecedent with this, I'm going to say choose delta equals epsilon over 5. And now I'm going to start the argument. I'm going to say assume x minus 7 less than delta. We chose delta equals epsilon over 5, so this is x minus 7 less than epsilon over 5. I'm going to multiply both sides. I'm going to multiply both sides now by 5. So 5 x minus 7 less than epsilon. I'm going to distribute the 5 and include a minus sign as well without changing anything because there's an absolute value here. So x minus 7 and now I'm going to distribute this. So this is absolute value negative 5x plus 35 less than epsilon. And now this is going to be, what did I start out with? The consequent I'm trying to show is negative 5x plus 1. And then minus negative 34. This is the consequent. So I started out with the antecedent. I assumed that was true, and then I showed step by step how to get what's in the consequent. And so the proof is done. I can say that by the precise definition, the limit of as x goes to 7 of negative 5x plus 1 equals negative 34.